Spice Math. That's right. Keep adding up, multiply, man. Spice Math. Okay. A couple things we're gonna learn today. Spice Math. All right. Take some time, educate yourself. Spice Math. That's right. You won't believe it's just math. Come on.
Hi, I'm Ruth Dottin.
Hi, I'm Erin Williams.
Hi, I'm Brandon Alexander.
Hi, I'm Kelvin Dottin.
Hello, I'm Lyndon Sincere.
We are your Spice Math tutors.
You won't believe it's just math. Just math.
Hey guys, welcome to another episode of Spice Math. I am Marvin Phillip, your Spice Math teacher. Today our focus is finding the highest common factor. Our target would be persons from the age 11 to 13, more specifically persons in Form 1 to Form 3. The objectives for today are for you, the students, to be able to define factors, to find factors of a number by expressing that number as a product of its prime factors, and to be able to identify the highest common factor between numbers. What you need to know before starting with me today. First of all, I want you to be able to define what a prime number is. And a prime number is defined as a natural number that is greater than the digit 1. But wait, that's not all. Prime numbers only have two factors. These two factors are the number itself and the digit 1. The quotient is what we call the result of the operation division. And finally, what is a composite number? A composite number is a number that has more than two factors. Let's get to the source. What is a factor? Before we can dive into identifying the highest common factor between numbers, we have to be able to define and find the factors of numbers. And you have to be able to tell what a factor is. And a factor is a number that divides exactly into another number. When I say the word exactly, I am referring to that number leaving no remainder. All composite numbers always have at least two factors. Those two factors are itself and the digit 1. Now, for us to be able to find the other factors of composite numbers, we can use the method by identifying or finding the product of its prime numbers. How do we do that? Let me demonstrate. If I have the numbers 36 and the number 48. Now, first of all, I want us to be able to find the factors of the number 36. We can state that the established factors of 36 would be 36 and 1, meaning itself and the digit 1. So to begin, we can list two of the factors here already of 36, being 1 and 36. Now, for me to get the remaining factors, I can continuously divide the number 36 by the lowest possible prime numbers. Let's see. The first prime number I can divide 36 by is 2. When I divide 36 by 2, it leaves me with the quotient being 18. Then I realize I can divide 18 by 2 again. When I divide 18 by 2, it leaves me with the quotient 9. Can I use 2 again to divide 9? No, because it's going to leave a remainder. So now I'm going to divide 9 by the next prime factor, which is 3. When I divide 9 by 3, the quotient now is 3. Now, in the rules, you would have seen that I said to divide until the quotient is equal to 1. So now, I can divide 3 again by itself, 3. And it leaves me with the quotient being 1. So for me to express the number 36 as a product of prime factors, all my prime factors are listed on the side here. So 36 can be represented by the multiplication of 2 by 2 times 3 times 3. Now, in order for me to identify these other factors, I would now have to group the numbers using the associative law. And the associative law tells me that for an operation to be associative, no matter how I group the terms, it will give me the same result. So multiplication is deemed to be an operation that is associative. So it is okay for me to group these terms here differently because I'm going to get the same result. So first of all, I'm going to multiply the number 2 by 2 by 3 by 3. So what does this give me? This tells me it's 2 multiplied by 2 by 3 is 6, and 6 by 3 is 18. Now I would have found an additional 2 factors of 36. Now I have to group differently again. I have 2 by 2 by 3 by 3. What do you think? Let's group 2 by 2 and then 3 by 3. 2 by 2 gives me 4 and 3 by 3 gives me 9. What I did there, I found 2 additional factors of 36. Am I done? No, we're not finished as yet. Let's try another combination. 2 by 2 by 3 by 3. How about this? 2 by 2 by 3 multiplied by 3. 2 by 2 is 4. 4 times 3 gives me 12. And then 12 by 3 gives me 36. So I then found 2 additional factors, being 12 and 3. Now, sometimes at this point, persons may think that they would have found all the factors. But remember at the beginning I said we have to be creative in how we combine the numbers. So if I write the product of the prime factors again, let me show you my creativity. I can multiply 2 by 3, and I can also multiply 2 by 3. And what this resembles is simply somebody wearing a pair of headphones. So 2 by 3 gives me 6, and 2 by 3 gives me 6. So what I was able to find here were 2, well, should I say 2? It looks like 2, but indeed 6 is the same as 6. So it means that I found one additional factor here. So in order for me to list all my factors of 36, I must remember, first of all, composite numbers have at least 2 factors. And these 2 first factors would be the number, or the digit 1, and the number itself. So I know 1 and 36 are already factors, and I found all my additional factors here. Now students, I must remind you, in all that you do, we must be neat. So we are going to write our factors in ascending order. So my factors of 36 would be 1. What's the next number? We're going in order. 2. What do you see again? I see 1, 18, 4, 9, 12. I can go now to 3. Then 4. Then I can go now to 6. Then I go to 9. I go now to 12. Follow me. We now have 18. And the final factor of 36 would be itself 36. These are the factors of 36. Now, in the comfort of your home, I now ask you to find the factors of 48. We'll be right back. How did you do? Did you get the factors of 48? This is my working. You're going to check it with yours. We found 48 as the product of its prime factors, being 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3. I went ahead and I combined them for me to get all my additional factors. I got 2 times 24, 4 times 12, 8 times 6, and 16 times 3. So all these numbers here, double underlined, are factors of 48. Now all I did, I wrote my factors in ascending order. 1. Now where did I get 1? Remember I told you that the number itself and 1 are established factors. They are always part of the solution set of the factors of a particular number. So now my factors are 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. Did you get that? If you did, ask your parents to make you your favorite meal tonight. Now that we've found all the factors of 36 and 48, can you tell me what is the highest common factor? But first, let us identify all the common factors. 1 is common. 2 is common. 3, 4, 6, and finally, 12. Now, out of all the common factors, which one is the highest? The HCF would be equal to 12. Now, just to backtrack a bit, remember before we represented 36 and 48 as the product of its prime factors. Now, there's an easy way for us to identify the highest common factor at this point as well. By looking at all the common numbers being multiplied. So let's see. 2 is common here in both 36 and 48, multiplied by 2, which is common in both 36 and 48. But then I now go to 3, which is common in 36, and is common with this 3 in 48. So to identify my highest common factor, all I have to do is multiply these common prime factors. So the highest common factors will be found by multiplying 2 by 2 by the other common prime factor, 3. And 2 times 2 gives me 4. 4 times 3 gives me 12. So at this point, we can also conclude that the HCF between 36 and 48 is 12. Time to do it on your own. Find the HCF of the following pairs of numbers. This is a solution. Compared to your answer, I hope you got it right. Thank you for your time and for tuning in to this episode of Spice Math. See you next time.
A couple things we're gonna learn today. Spice Math. All right. Take some time, educate yourself. Spice Math. That's right. You won't believe it's just math. Come on. You won't believe it's just math.